Uh, direct and
Shut up.
be quiet. Direct and inverse variation. Okay, an example of direct variation would be, so let's say we're trying to make some money and we're selling t-shirts, and every t-shirt we sell makes $10. How would I write that? We'll say P, our profit, equals what? 10, we'll say T for t-shirt. Okay, $10 times the number of t-shirts we sell. Okay, so profit equals 10 times T. This is an example of direct variation. What makes direct variation is that when one number goes up, the other number goes up by some common multiplier. So the more t-shirts we sell, when that goes up, the more profit we get, that goes up. This number that is in here is called the constant of variation. And it basically tells us our profit is going to go up 10 times faster than the number of t-shirts we sell. But anyway, so the general form of direct variation is A equals KB. So K is the constant of variation. A and B could be a lot of things. Like when T is 5, like if we sold 5 t-shirts, what would our profit be? If we sold 5 t-shirts, what would our profit be? 50. 10 times 5. If we sold 8 t-shirts, what would our profit be? 80. Okay, so anyway, that's what it looks like. This is the general form. A and B are going to stay A and B because there's a lot of things that they could be. P and T could be a lot of things. But this number in front of T, the constant of variation, there's only one thing it can be, so you kind of have to, we're going to be figuring that out, basically. Okay.
You're gonna crash out.
Smells really good in here.
It smells like trash. Does Jordan smell it?
Yeah.
Poor Aiden.
Mr.
She
Jordan
can't
likes it.
go back then.
We should open
If
the
you
door so
Actually,
he
it's
Spray it in the
smells
thing.
it.
I think Wyatt tried to do that. Yeah.
I tried to what?
Throw it into the bin.
Yeah, I tried.
Okay, the other kind that we're doing is called inverse variation. So inverse variation, you might be able to guess, when one of the variables goes up, the other one goes down. That's what inverse means. One goes up, the other goes down. So it looks a little different. A very common example, there's different examples we could use, but the one I always think of is the faster that you drive someplace, how does that affect the time that it takes to get there? Right. As the driving speed goes up, the time to get there goes down. So that's inverse variation. What would that look like as a problem? Well, you guys remember distance equals rate times time. Also, rate equals distance divided by time if you mess with that little formula. So let's say our distance is like 50 miles, like we're going to Tulsa or something. If you start, it depends on like where you start at. From here, probably about, yeah, it's probably pretty close to 50. I think on the south side of Tulsa, it's like 47, or south side of Bartlesville, it's 47 miles. I think, I don't remember for sure. But anyways, so let's say T is 1, like we spent 1 hour traveling to get there. That'd be slow, but what would the rate be? 50 divided by 1. If we spend 1 hour to get there, our rate would need to be 50 miles per hour. Okay, that doesn't make a lot of sense because you probably wouldn't go 50, but you guys get the idea. If the time is 2 hours, how long would it take us? What would our rate need to be to get there? 50 divided by 2 is 25 miles per hour. So as the time is increasing, the rate is decreasing, or vice versa. As the rate increases, the time decreases. So all inverse variations kind of look like this, though. So one of the variables is in the denominator. The constant of variation is still on top, but one of the variables is in the denominator. So the general formula is like A equals K over B. K is the constant of variation, like 50, and one of the variables is in the denominator. All right, so this only applies to the first like 6 problems. These 2 formulas. So this is for direct variation. This is for inverse variation, where K is the constant of variation. There's some number going to be in the K spot. Okay, so number 1, here's how it goes. 2 quantities A and B vary directly. So which one are we going to use? This one. Okay, A and B vary directly. So we're going to use this formula. Then it says when A is 7, B is 21. When A is 7, B is 21. We can use that information to figure out what K is, what the constant of variation must be. How do I solve this for K? Divide. What is 7 divided by 21?
3.
No.
-3.
No.
7 over 7, 23.
Well, yeah, it's 7 over 21, but what's that change into? 1/3. It's a fraction. It is 21 divided by 7 is 3, but 7 divided by 21 is 1/3. The divisor is larger than the dividend. So anyways, it's 1/3, not 3. Okay, that's kind of the answer, but not exactly. So the answer is actually this equation up here, but we're just going to replace the K with what we figured out K is. A equals 1/3 B. Okay, why are we leaving A and B as A and B? Because they can actually be an infinite number of things. So we just leave them as A and B. The K can only be one thing, and we're kind of figuring out what that is.
Wait a minute.
Yeah.
Would it be wrong if it's A equals 1/3 higher?
Yes, it'd be wrong. A and B needs to say A and B. 21 is only one thing that B can be. So
How
it's
do you know
confusing.
if it's...
All we're doing is plugging in the numbers in they give us and solving for K.
Never mind, I got it.
Okay, so let's try again. Number 3 is kind of the same thing. 3 says M and N vary directly. M and N vary directly. So how are we going to set this up?
Times.
M equals
Really?
K times N. Okay, and then they tell us when M is 4, N is 14. When M is 4, N is 14. How do I solve this for K?
Divide by 14.
All right, 4 divided by 14. 4 14ths, 2 7ths. Okay, if you divide those both by 2, you just got to reduce. 2 7ths. I do not want the decimal version of these because they're not pretty. Most of them. Some of them are. But yeah, just leave it as 2 7ths. So is that the answer? Kind of. It's part of the answer. It's M equals 2 7ths N.
This is easy.
So far, yeah. We're using the direct variation formula. We're plugging in the numbers they give us and figuring out what K is.
Question. Wait a minute. How do you know what?
Great.
Ah.
Okay, on numbers 4 and 5, it says varies inversely. So if it varies inversely, actually gonna do number 4. If it varies inversely, what are we gonna use? This one. Okay, 4 says R varies inversely as S. R varies inversely as S. So this is, they didn't give us A and B, they gave us R and S. So this is the version we're going to use. Then it says when R is 3, S is 15. When R is 3, S is 15. How do I solve this for K?
Times 15.
Times 15. Because that gets rid of a divide by 15. 3 times 15, 45.
Big boy.
Allison knows. Alright, so we're going to take this 45 and put it back into the formula. R equals 45 over S.
Wait, is this number 4?
Yeah.
Alright.
Put it on number 5.
Why do you have house on your board?
Some kid was drawing random stuff just like you do.
Hey, mine is not random.
Yes, it
Yours
is.
is trash.
It is the wrong
You're from
season.
one top.
Bro, we're barely in November.
It is November
6.
6th.
It's barely in November.
We're not even a week in November yet.
Merry Christmas.
Okay, number 5. I want to do 2 of these. That's why I'm doing 4 and 5. So 5 also says T and U vary inversely. So how am I going to start? T. Okay. T and U vary inversely.
This number 5.
Yes. Okay. Then it says when T is 8, U is 4. When T is 8, U is 4.
Times 4.
Times 4 to solve for K. Alright. So now we know that K must be 32. We're going to rewrite the formula with K as 32.
Wait, so what is K mean?
It's called the constant variation. It just kind of tells you how much faster one's going up when the other's going down.
Okay,
Or
but how do you know like how to set it up?
if it's inversely, we're going to use this pattern.
Well, I know that, but like, how do you know if like J
Sure.
or K comes first? Like,
Just the one they list first comes
Okay.
first. It kind of works both directions, but just do the one, whatever they put first, you put first. Okay. Then number 7, it changes again, the pattern, problem.
Oh, it says it.
The problem types change again. So did everybody take good notes on that first, this part, like this stuff for notes?
sure.
Yeah, I just-
I have
Okay.
a question though. Like
Yeah.
on number 2, they use K as one of the things. Just change it to a different letter.
Yeah. The letters don't really. Our book uses K, even though I'm using a worksheet right now, so I just use K, but there's nothing really special about the letters. Okay. So, I don't know if I can explain why this next part works. Maybe I shouldn't even try. Just explain how to do it.
I say we just figure out how to do it.
We'll just figure out how to do it.
Yeah, it's probably not gonna do
it.
Okay, so on this next part, what they're gonna do is give us, they're gonna, listen, they're gonna say something like, if A equals this when B equals this, find B when A is this. So, I'll write it down. If A equals 3 when B equals like 6, find A when
we do write this in?
Find A when B is 10 or something, whatever, doesn't matter.
Let's do.
Okay, if this is varies directly, here's how we're gonna set it up. If it varies directly, then it's proportion basically, like A over B should equal A over B. You guys remember solving these? It's been a couple chapters.
Yeah.
So if I plug in A is 3 when B is 6, find A when B is 10. Okay, how did we solve these back in the cross multiply? 6 times A equals 3 times 10. 6A equals 30, so the A value would have to be 5. So basically it's a proportion problem. If they had said inversely, listen, if they had said inversely, we would actually use this formula. A times B equals A times B. So 3 times 6 equals A times 10. And then you just solve that. 3 times 6 is 18. Divide by 10. And this would be like 1.8. Or they do use decimals on this worksheet instead of fractions. But I don't really care either way.
Oh,
That was an example. Too late. Time's up. All right. Now, number 7. It says, it is known that P varies inversely with Q. P and Q are inverse. So when P is 4, Q is 5, find Q. Find Q when P is 8. Listen, Draven. This is why you always don't know what's going on.
What? No. I'm perfectly.
Perfectly lost. P and Q vary inversely. So what formula did I just say we're using when P and Q are inversely? Right. AB equals AB. So in this case it's P and Q though. So it's PQ equals PQ. And we're just going to plug in the stuff that they give us. So P is 4 when Q is 5. What's it mean when the letters are right next to each other? Multiply. Alright. And then it says find Q when P is 8. Find Q when P is 8. Okay, so 4 times 5 is 20. What would we do to solve that for Q? Divide by 8. It doesn't divide really well, but I think 20 divided by 8 reduces to 5 halves.
what is that? Oh, this is big Q.
Alright. Number 9. It is known that H varies inversely with I. So what are we going to use?
What happens if it's not a capital Q?
The same thing. H times I equals H times I. Hi, yes.
5 times how?
So when H is 6, I is 18. Find number 9. Find H when I is 12.
I thought number 8. It's number 9.
There. Alright. How do I find H here? 6 times 18 is 108. Then what do I do? Divide by 12.
Wait a minute. Ah. Why are we doing so fast? 9.
I'm gonna do number 10 next, because it's the first varies directly. So it's been a while since I wrote this down. What are we gonna use for varies directly? A over B equals A over B. Right here. So on number 10, it says F varies directly with G. So it's F over G equals F over G. When F equals 8, G equals 12.
Over 12 equals
Read the
8
problem.
over 12.
When F equals 8, G equals 12.
Oh, we're doing.
Find G when F is 24.
What?
F is 24, find G.
So you'll do 8G
8G,
equals whatever 12 times 24
12
is.
times 24. Okay, so whatever this is, what would we do after that? Divide by 8. You could plug this in your calculator all at once. 12 times 24 divided by 8. 24 divided by 8 is 3, 3 times 12. It's going to come out as
12 times 24 is 3.
24 divided by 8 is 3.
Ah.
So it's just going to come out basically as 3 times 12, 36.
Are we only going to 12 or are we going all the way through?
All the way. Okay, number 11 also varies directly. So we're using the same formula. F varies directly as G again. So we're using the same formula. Uh-oh. How did that happen? I think I broke it.
You broke your own motion.
Did you buy it
Okay. It says when F equals 11, G is 3. F is 11, G is 3. Find G when F is 22.
11G equals 22 times 3. That's not necessary science.
Yeah, 11G is 66. You guys probably know this one. What's 66 divided by 11?
6.
Six.
Smart. We can do that tomorrow. Wait a minute. Hold on. I kind of forgot what I was doing. Wait. 11 equals 66. 11. G equals 6.
Okay, 13, so that's a little bit different. Every time your heart beats, it moves 60 milliliters of blood through your system. Is that a direct or inverse variation? So as your heart beats more, the blood pumps more, right? So is that when one goes up, the other goes up? Is that direct or inverse?
Right.
Correct. The more your heart beats, the more the blood pumps. That's direct.
Part of that? No.
Okay, 15. A person's resting heart rate is 60 beats per minute. That means when you're just sitting down.
Did you say 14?
15. A person's resting heartbeat is 60 beats per minute. But when exercising, the rate goes up to 100 beats per minute.
Varies.
Will the amount of blood pumped increase or decrease? Increase. It's kind of a silly question, but basically they're trying to point out when one goes up, the other goes up. So they probably should have put that problem before 15, before 13. Okay, 17. This goes back to the math part. When your pulse rate is 70 beats per minute, your heart pumps 350 milliliters of blood each minute. How much blood will it pump when your pulse is 80 beats per minute? Okay, so on 13 we said this is a direct variation. So which formula are we going to use to solve this?
A equals K times B.
Not that one.
Oh.
No. This is the one where they give you two numbers and then a third number and you're supposed
H
to find.
times I equals H times I.
No, that's inverse.
F over G equals F over
Yeah,
G.
same as the ones we were just doing. Yeah, this is direct. Yeah, and they didn't really give us F and G's. They gave us, what did they give us? Pulse rate and,
70, 350, and 80.
yeah, milliliters of blood. Yeah, anyway, it's
70 over 350,
70 goes with 350.
G over G.
Yeah. Should the 80 beats per minute go on top or on bottom?
Awesome.
Top. Should go across from the 70 beats per minute. And they want to know X, how much blood are you pumping at 80 beats per minute? So, cross, multiply.
I don't know what 80 times 350 is. And figure it out.
What's 8 times
Okay,
35?
okay.
Add a 0.
Go candy.
Sage advice. Okay.
Oh, good.
So, to solve, we're going to divide by 70, right? Whatever this is, divide by 70. You can kind of cheat a little bit and do that. Should come out as
400.
400 milliliters.